Alright, ladies and gentlemen, welcome back to another edition of Mr. Mossman Notes. Today we're talking about ellipses. This is our second conic shape that we're describing. When you tilt that plane, it makes a oval, is another name for this description. So it takes your circle and it stretches it a little bit. That's an oval, also called an ellipse is what we're talking about today. Because it can stretch in two different directions, we have two different orientations. That's what these are called. It can be a horizontal ellipse or a vertical ellipse. The thing that decides that is in the standard form. Notice our standard form, H and K, just like circles, that's our center. Except this time, our radius has been replaced with a 1, so that must be a 1 for an ellipse. And then we've got these different numbers underneath the x and y squared terms. If it is bigger number under the x, that means it's stretching in the x direction, so it is a horizontal ellipse. If the bigger number is under the y, it's stretching in the vertical direction. A and B will come in handy in knowing which one is A. So in this case, the A's are the bigger one, and we'll talk more about that in a minute. But basically, if the bigger number is under x, it's horizontal. Bigger number under y, it is vertical. So we still have our center. That's still H and K. We talked about that. But we've got these things called vertices and covertices. Vertices are at the end of the long line, and that long line is called our major axis. So the major axis is the long one, and the vertexes or vertices are on the end of that. However, we also have endpoints of our short line. The short line is called the minor axis, and its endpoints are called covertices. These are all important to understand in case you're given specific parts and need to write the equation. Remember, we will be graphing with Desmos, so that's going to help, but we still need to understand all of these pieces. All right, so our center is H and K. Here's the nice thing. This number a squared underneath x gives us the orientation here, but the square root of a squared is a, and that is the length from the center to a vertex. That is very nice. That length right there is a. All right? So therefore, the length of the major axis is 2a, and then the length from the center to a covertice is b, so therefore the length for the minor axis is 2b. Okay? Those could be given to you, but it's very handy to know. The focus. This is the first time that we've got a different, weird, important point. The center of the circle is important. The focus is important about the ellipse. Okay? And it lies on the major axis. That's important. So if we have this horizontal ellipse here, our focus are these 2 points right here in the middle. Okay? It is, the definition of an ellipse is all of the points, so that's our circle, all of these points, whose sum of the distances from two fixed points is constant. So we take these two focuses and we connect any point on our ellipse, and these two things added together is the same for any other point on that ellipse. So these two distances added together, these two distances added together, and that's what makes, so all of these distances that you connect here, that's what makes an ellipse, is these two distances added together. Now, the focus is the important point, so we're going to have to find that, and here's the good news. The focus is directly related to A and B. We've got this nice little formula, so we definitely need to keep that in our back pocket. C squared is equal to a squared minus b squared. Very similar to Pythagorean theorem because we do have triangles here, but not quite the same. So we just need to memorize this for an ellipse. It's going to be different for a hyperbola. But we use this to find c because we will know a and b from our equation, right? And we use this to find c, and then we add it to the correct coordinates to find where our focus lie on the graph. We'll come back to that in a minute. But it is c distance away from the center. All right, so here's our center. This distance is c. This distance here is c. So we're going to take our center and add c. And we'll, again, I'll show you that here in a minute. So the foci are the 2 points inside of an ellipse. That's important because next time they won't be. And they're always on the major axis. If the major and minor axis are the same length, so if this was the same length as that, it would be a circle. And both foci move to the center. Okay? We can see what that looks like in all of these features if you click on this link and explore the Desmos slider explanation. Okay? But you guys like math, so let's get into the math. Here we go. First example A. We've got x minus 3 over 36. Sorry, x minus 3 squared over 36 plus y plus 1 squared over 9. First thing that comes up is orientation. The bigger number is under x, which makes it horizontal. Okay? Horizontal, because the bigger number is under x. The center, that's old news. H and K, don't forget it's the opposite, so positive 3, negative 1. I'm going to go ahead and graph as I do this so we can kind of see it come together. 1, 2, 3, negative 1. There's our center, right there. And the rest of this needs calculation. So remember, the vertices are on the major axis right here, and we need to take the square root of the biggest number under the bottom. Square root of 36 is 6. So therefore, our major axis length is going to be 2 times 6, which is 12. And you'll see where that comes here in a minute. But we know that since it's horizontal, this 6 is the distance from the center to the vertice. 1, 2, 3, 4, 5, 6. There is one vertice at 9, negative 1. And then from the center, 1, 2, 3, 4, 5, 6. There's our other vertice at negative 3, negative 1. Notice, because the vertices lie on the major axis, the y value is still the same. Okay? All right, our covertices are based upon the smaller number, so we take the square root of 9 and we get 3. That is the length of half, so if we multiply that by 2, the length of our minor axis is 6. So in this case, the minor axis goes up and down, so we go 1, 2, 3 up, and 1, 2, 3 down, and there is our covertices. Positive 3, 2, and positive 3, negative 4. Be careful counting that one. Positive 3, negative 4. Do notice that the x values there are the same as our center because they lie up and down from the center. There's our ellipse, ladies and gentlemen. We have just graphed it, and that is how we're going to get there from these pieces. Again, the major axis length is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The minor axis is 6. 1, 2, 3, 4, 5, 6. And then the foci. This is the hard part. We have to remember that the foci are somewhere in here, a distance of c away. So here's how we find it. We use our formula c squared equals a squared minus b squared. There's a and there's b. And notice a squared is that original number, 36. So c squared is equal to 6 squared minus 3 squared, which is c squared equal to 36 minus 9, which is 25. Thank goodness, because we don't need c squared, we need c. You take the square root, and you get c equals 5. Now again, that is not our focus. That is the distance from the center. 1, 2, 3, 4, 5. There's our c value, so there's our focus. Negative 2, negative 1. And then again, 1, 2, 3, 4, 5. There's our focus there as well. Positive 8, negative 1. So good connections. The y value is still the same as the center because they're still on this horizontal line. But negative 3 plus 5 is 8, and negative 3 minus 5 is negative 2. Okay, let's do some more. Don't forget to pause, stop, take a beat, take a breath. Write an equation from the ellipse with each set of characteristics. This one is a good one for you to try because you should know what these numbers are. And so you try that one, and then check the copy of notes. I'm going to do this one because it's a little bit trickier. So our vertices at negative 4, 4. Always plot the points it gives you. And 6, 4. 1, 2, 3, 4. Good. Our focus is at negative 2, 4. Okay. And 4, 4. That's excellent. This is great. Because those are our vertices, we know this is a horizontal orientation because that makes this our major axis. Yes, that is good. We know, and also the focus lie on that, so therefore we know it's our major axis. The center is relatively easy to find. 1, 2, 3, 4, 5, 6. So half of 6 is 3. 1, 2, 3. That has to be our center, which is 1, 4. That's a big part of our equation. Watch how I do this. I'm going to do this. X minus blank squared plus y minus blank squared equals 1. This is the standard form. The center is 1, 4, so 1, 4. I'm almost there. Now, because I know this is a horizontal orientation, this distance here is A, and that distance is 1, 2, 3, 4, 5. And because it's horizontal, I know it goes under the x. So 5 squared. All I need now is B, and that comes from our focus information. C squared equals A squared minus B squared. A squared has to be 5 squared because that's the bigger number, because it's a horizontal orientation. C squared is what we can find because we have the focus here. Our focus is right here, so therefore C is this distance of 3. Alright, sorry that's kind of small, but if you're listening, you will understand. So 3 squared, and we're looking for B squared. Now we just have to solve. 9, 25. 9 minus 25, when we move that over, gets us negative 16. Divide both by negative 1. Perfect. Take the square root of b squared, and you get b equals 4. 4 squared, which means from here I go 1, 2, 3, 4. Man, I made that perfect. 1, 2, 3, 4. There is our ellipse. But more importantly, there is our equation. You would write it x minus 1 squared over 25 plus y minus 4 squared over 16 equals 1. All right. One more example. I know this is long. I'm going to do this one. Then you're going to do this one and check the copy of notes. This is the important part. We have an ugly non-standard form, so we have to complete the square. Step 1, group your x's and y's. 4x squared plus 24x plus y squared minus 10y equals 3. We're going to leave that guy over there for now. You'll see why here in a minute. A's will show up, so that means we have to factor out an A. And this is where I add my spaces as well. 4 parentheses x squared plus 6, because 24 divided by 4 is 6, plus space, plus this one doesn't have an A, so it doesn't require one. I'm going to use parentheses just so I can see it the same. Y squared minus 10y plus space, close parentheses, equals 3. Now, because I added some spaces here, I've got to add some spaces. Because I'm already putting them on the right side of the equation, that means I can add on this side and add on this side. Be very careful though, because this space is not just a space, it's a 4 times a space. This space is just a space. Alright, now to stay organized, this is going to be my red chunk. Red. This is going to be my blue chunk. Blue. That way I don't forget and don't get mixed up. Alright, here comes our magic. B divided by 2 squared. So b is 6 divided by 2 squared gives us 3 squared, which is 9. That number goes here. and over here in the red space, but I use this number 3 for my standard form. Alright, now to the red one. Negative 10 divided by 2 squared, because that's b, is negative 5 squared, which is 25. Sorry, I'm getting kind of squishy here. But that goes in my blue space, 25, 25, and y minus 5 squared. And then I'm just going to throw an equal and put all of this junk together. And I'm going to use my calculator because I'm lazy. 3 plus 4 times 9 plus 25 is 64. And then the last step, we got to get rid of that a. No, we don't. Well, we will get rid of it. What we need is for this number to be a 1. So divide everything by that number. 64, 64, 64. And what happens is we get 1 y minus 5 squared over 64. And 4 over 64 simplifies to over 16. X plus 3 squared over 16. Alright? Now we just go back to the old problem. The bigger number is under y, so that is a vertical. The center is at negative 3, 5. Our major axis length, square root of 16 is 4. Square root of 64 is 8. That's the bigger number, so that's our major axis. 2 times 8 is 16. The minor axis length, 2 times 4 is 8. Now our focus, the other math part, we need c. C squared equals a squared minus b squared. A squared is 64. B squared is 16. 64 minus 16 is 48. And this part's fun because we take the square root of that and we get not a whole number. 6.9. So we're going to call it the square root of 48. Now, here's an important feature, okay? Watch what happens here. I'm going to graph this. Negative 3, 1, 2, 3, 5, 1, 2, 3, 4, 5. That's my center. Major is vertical, so I need to go up 8, a little bit off, that's okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then my minor is 4, 1, 2, 3, 4. 1, 2, 3, 4. So there's my beautiful graph, but my focus is what's next. It is square root of 48. It's 6.9, guys. So you go 1, 2, 3, 4, 5, 6.9. 1, 2, 3, 4, 5, 6.9. There's where they are, but that's not good enough. So we write our focus like this. Because I know I'm going up and down, I'm not changing my x value. So my focus x value is negative 3, comma, negative 3, comma. I'm changing my y value by adding the square root of 48. 5 plus the square root of 48. I'm changing my y value by subtracting the square root of 48. 5 minus the square root of 48. This is what we're going to want to see on our assessment, ladies and gentlemen. And if you type that in Desmos, it'll plot those focuses for you perfectly. Please let us know if you have any questions. Less than 20 minutes. Sorry, that was so long.